To get the most from your Linux hacking system, you need to understand environment variables and be adapted at managing them for optimal performance, convenience, and even stealth. So among the areas that Linux newcomers find problematic, however, managing the user environment variables might be the most difficult to master. So technically, there are two types of variables. The first is shell and the second is environment. So environment variables are system-wide variables built into your system and interface that control the way your system looks, acts, and feels to the user, and they are inherited by any child shells or processors. So shell variables, on the other hand, are typically listed in lowercase and are only valid in the shell they are set in. So to avoid over-explanation, I just cover some of the most basic and useful skills for environment and shell variables in these lectures, and don't go too deeply into the differences between them. So variables are simply strings in key value pairs. So generally each pair will look like this, for example, key and value, key here and value here. So in cases where there are multiple values, they will look like this here: value 1, value 2, and value 3, and vice versa here. So as with the most things in Linux, if there are spaces in the value, it needs to be contained in a quotation marks here, like that. Value 4. So in Kali Linux, your environment in your bash shell is your bash shell. So each user, including root, has a default set of environment variables that determine how the system looks, acts, and feels. So you can change the values for these variables to make your system work more efficiently, tailor your work environment to best meet your individual needs, and potentially cover your tracks if you need to. So viewing and modifying environment variables. So you can view all your default environment variables by entering any v into your terminal from any directory, like so here. So as you can see, there is my environment variables here. So environment variables are always uppercase, as you can see here. Including shell variables, local variables, and shell functions, such as any user-defined variables and command aliases. So use the set command. This command will list all environment variables unique to your system, which is the most cases will give you an output, so long you won't be able to view it all on a single screen here. As you can see here, we have so many environment variables here. As you can see here, we can see because it's so many here. So we can do like that, set here, set, and more here. Now we can see like that by pressing enter. We can see sequentially. So let's see more, and press in one time Control and C or X to quit here. So now the list variables here, as you can see here, will fill up on a screen line by line and then stop. When you press enter like that, or space, or in space, you will see more here. Taking you to the next variable, so you can scroll through pressing or holding enter like that. So as you might recall from previous chapters and lectures, whenever you use the more command for output, you can enter key Q to or exit and return command to prompt here, Q here like that, or Control plus X here. So filtering for particular variables. Let me see here. So although using set with more gives more manageable results than looking through the huge chunk of variable names you get with the set alone like that. It can still be rather tedious if you are looking for a particular variable. Instead, you can use the filtering command grep to find your variable of interest. So let's use the variable hist size as an example. So this variable contains hist size. This variable contains the maximum number of comments your command history file will store. So hist size is the maximum number of commands your command history file will store. Those commands are any ones you have previously typed into your command prompt in the session and can be recalled with your up here, up and down keywords like that. So note that the hist size doesn't store the commands themselves, just a number of them that can be stored. So pipe your set here, set output grep, actually grep hist size here. As you can see, his size is 1000. As you can see, the command finds the variable hist size and displays its value. The default value of this variable is probably set to 1000 here, as you can see on your system too. So this indicates the terminal will store your last 1000 commands by default. Changing variable values for a session. So now let's see how to change a variable's value. As noted here, the hist size variable contains the value of the number of commands to store in the history file. Sometimes you won't want your system to save past commands, perhaps because you don't want to leave any evidence of your activity on your own system or a target system. So in that case, you can set the hist size variable to 0, so the system won't store any of your past commands. Because this variable has a single value, to change it, you assign it a new value in the familiar way here. So hist size here, hist size, for example, 0. So we assigned it. Now when you try use up here, up and down keywords to recall your commands, nothing happens because the system no longer stores them here. As you can see here, nothing happens here. So this is stealthy, although it can be inconvenient. So I will change this to 1000 back. So making variable value changes permanent. So when you change an environment variable, that change only occurs in that particular environment. In this case, the environment is the bash shell session. So this means that when you close the terminal here, for example, so when you close the terminal, any changes you made are lost. So with values set back to their default. So for example, his size 1, as you can see, is last commands is not working. When we close that and open it again, for example, as you can see here, we can see our his size here. So now we will change it permanently. So if you want to make the change permanent, so you need to use the export command. So this command will export a new value from your current environment, this is the bash shell, to the rest of the system. So making it available in every environment until you change and export it again. So variables are strings. So if you run on the cautious side, it isn't bad idea to save the contents of a variable to a text file before you modify it. So for example, since we're about to change the ps1 variable, which controls the information you display in the prompt. So the first run the command to save the existing files to a text file in the current user's home directory. So echo here hist size, and then this means our home directory, and value of our a value of my hist size dot txt here. Oops, I actually write an export here, so we don't need export. So ls, and as you can see here, value of my hist size is here. So let's read it with cat command. Value of my hist size, as you can see, there's a 1000. We write it, so we can open it with mousepad as well. Here, value of my hist size, as you can see, let's open it, and as you can see, there is a 1000 here. So let's close it. I will show more examples. So this way you can always undo your changes. If you want to be even more cautious to create a text file with all the current settings, you can save the output of the set command to a text file with a command like this, for example, set here value of all, and for example time, or let's write our hour here on 11:49 here, 11:49 and txt. So let's open it again, or we can value of all. As you can see, we printed all of these variables here. We can open it with our text viewer as well. As you can value of files, as you can see here, we have almost 238 lines of these set files here. So now the hist size variable will still be set to 0 when you leave this environment and enter another environment. If you want to reset here, let's actually change it firstly here. Clear and export hist size here. So now the hist size variable will set to 0. So when you leave this environment and enter another environment, if you want to reset the hist size to variable to 1000, simply enter this, for example, hist size 1000, and then export hist size. So this code will set your hist size variables value to 1000 and export it to all your environments here. Changing your shell prompt. Your shell prompt, another environment variable here, provides you with useful information such as the user you are operating as and or the directory in which you are currently working. So the default shell prompt in Kali takes the following here: user here, username, host name, and current directory. So if you are working with the root user, this translates to this, for example, root at Kali and current directory. So you can change the name in the default shell prompt by setting the value for the ps1 variable. So the ps1 variable has a set of placeholders for information you want to display in the prompt, including the name of the current user, the host name, and the base name of the current working directory. So this is very useful if you happen to have shells on multiple systems or are logged on as multiple accounts. So by setting different users and host names values for different shells or accounts, you can tell at a glance who you are and what your current system is. So let's have a little fun and change the prompt in your terminal. For example, you could enter here ps1 here, for example, world's best hacker here, and hashtag here. As you can see here now, our command prompt is like that here. So now every time you use this terminal, you will be reminded that you are the world's best hacker, but any subsequent terminal you open will still have the default command prompt, because the ps1 variable only holds values for your terminal session. Remember, until you export a variable, it is only good for that session. So if you really like this new command prompt and want to see it in every terminal, you need to export it. So like that, export ps1, but I will not do it in this here. So this will make the chains, so chain the permanent across all sessions. How about a little more fun here? So say you really want your terminal to look like the Windows CMD prompt. So let's actually, it's quite boring actually here. So say you really want your terminal to look like a Windows CMD prompt. So in this case, you could change the prompt name C and keep the W, have the prompt show your current directory as here, for example, export ps1, actually not ps1, and here this will be cmd here, so we C, and here we will write W for directory here, as you can see here. Here, like that. Or we can do it, for example, cd downloads, like that. So having your prompt show your current directory can be generally useful, so particular to a beginner. So it's something to consider when you change your ps1 variable. We can change path as well. So one of the most important variables in your environment is path variable. Actually, it's boring actually. So let's close it. So one of the most important variables in your environment is your path variable. So which controls where on your system your shell will look for commands you enter, such as a cd, ls, or echo here. So most commands are located in sbin or bin directory here, like user local sbin or user local bin here. If the bash file doesn't find the command in one of the directories in your path variable, it will return the command not found, like that, for example. Command not found here, like that. So even if that command does exist in a directory, not in your path. So you can find out which directories are stored in your path variable by using echo and $sign and path. As you can see here, this is our path here. These are the directories where your terminal will search for any command. When you enter ls, for example, the system knows to look in each of these directories for the ls command, and when it finds ls, the system executes it like that, ls. So each directory is separated by colon, and you don't forget to add the dollar symbol in content path here, as you can see here. So we can add to the path variable here. So you can probably see why it is important to know what is in your path variable. If you downloaded and installed a new tool, let's say, for example, new hacking tool here, into the root new hacking tool directory, you could only use commands from that tool when you are in that directory, because the directory is not in the path variable. Every time you wanted to use that tool, you would first have to navigate root new hacking tool, which is a bit inconvenient if you want to use tool often. So to be able to use this new tool for any directory, you need to add the directory to holding this tool to your path variable. To add new hacking tool to your path variable, enter this command path here, equals here $path and two dot here column here, and for example root new hacking tool here. We added path variable here, so this assigns the original path variable plus this folder here, directory, to the new path variable. So the variable contains everything it did before plus new tool directory. If you examine the contents of the path variable, again, you should see that this directory has been appended to the end of the path as shown here, echo path here. Oops. Echo path. As you can see, we added this our root new hacking tool here. So now you can execute new hacking tool applications from anywhere on your system, rather than having navigate to its directory. The bash shell will look in all directories listed for your new tool. So how not to add a path variable? So one mistake commonly made by new Linux users is assigning a new directory such as a root new hacking tool directly to the path variable like that. Path here, root new directory, root new hacking tool. So this will, if you use this command, your path variable will only contain the root new hacking tool. So your path variable will not contain this, and you will delete all of these path variables and only add this useless folder to it. So and no longer contain the system binaries directories such as bin and the swin. So after doing this command, you cannot use ls, cd or any commands here. So when you then go to use any of these commands, you will receive the error command not found here. So remember that you want to append to the path variable, not replace it. So if you are in doubt, save the contents of the variable somewhere before you modify it. So we can create a user-defined variable as well. So you can create your own custom user-defined variables in Linux by simply assigning a value to a new variable that you name. So this may be useful when you are doing the some more advanced shell scripting, or find you are often using a long command that you get tired of typing over and over. So the syntax is straightforward. Enter the name of your variable followed by assignment symbol, and then the value to put in the variable as here, for example, my new variable, and here, and for example, hacking is the most valuable skill set in the 21st century. Here. So this assigns a string to the variable my new variable. So to see the value in that variable, use the echo command and the $content symbol with the variable name, as we did earlier here, my new variable here. As you can see, we printed this. So just like our system environment variables, user-defined variables must be exported to persist to new sessions. So if you want to delete this new variable or any variable, use the unset command, unset my new variable here. So now let's echo, and as you can see, we have no new variable here. So because we deleted this variable with unset command and after pressing echo for printing to terminal, we can't see it because there is no variable here after unsetting this variable here. So lastly, you might find environment variables foreign, but it's worth getting to know them. So they control how your working environment in Linux looks, acts and feels. So you can manage these variables to tailor your environment to your needs by changing them, exporting them, and even creating your own, as we did in this case. So in some cases, they may be useful for covering your tracks as a hacker.